Welcome do-it-yourself and woodworking fans of cyberspace to Chip's Woodshop. My last video and Instructable were about the CNC router I made. This time, we walk through creating a single line design for engraving with a V-bit using freely available open source software. We'll be carving a simple stamp from an eraser. Whether you find it easier to follow a video, written instructions, or both, everything I show in this video is explained in an Instructable. You can get there from a link in the video description. Now let's make a stamp. Before you start, be aware of woodworking and power tool safety. Wear safety glasses and don't put yourself in the way of moving parts. Step 0 is installing the software. You can get the links in the video description. We'll use Inkscape, Hershey Text, PyCAM, Camatics, and Linux CNC. Hershey Text is a single-line font made for efficient engraving. It's not absolutely necessary, but my example uses it. Follow the instructions on the Hershey Text link to install after Inkscape is installed. Let's fire up Inkscape. First, we'll set our units to millimeters and make a rectangle about the size of our eraser. From the Extensions menu, click Render Hershey Text. Then create a single line text. I'll use Chip's Woodshop. Size and move the text. Flip horizontally so the stamp leaves a print in the right direction. From the File menu, click Save As. Select the Inkscape SVG file type. Start PyCAM. From the Settings menu, click Preferences. Set the units. I'm using millimeters in this example. Set a safe height above the working surface for rapid moves between cutting steps. We'll use 5 millimeters. From the File menu, click Open Model. Open the SVG file we made in Inkscape. Shift to Origin and Shift down. We will let Z equal 0 at the surface of the workpiece, so we shift the lines down to the depth we want to engrave, 0.5 millimeter. Click the Tool tab. There is no conical V-bit shape in PyCAM, but it doesn't matter in this case. We're simply telling PyCAM to put the toolpath right on the line, with no offset to worry about, so the tool shape doesn't have any effect. We'll just pick spherical instead, which will give us an idea what to expect in the visualization window. Click the Process tab. We're only carving 0.5 millimeter deep, all in one pass. We don't need any offset because we are following right on the lines with the point of the V-bit. Click the Bounds tab. We just need to establish bounds outside the area we're carving. Click the Task tab. Again, one single pass of the engraving process is all we need, using the tool we defined.
Click Generate Toolpath.
This is basically the Go button. Click the Toolpath tab. Simulate here to confirm the intended lines are cut. Next, we use Camatics to get a more accurate simulation. Why do we simulate? Running the program on a virtual machine is much safer. It takes very little extra time and saves you from crashing a tool or ruining your project.
Click Export All and save your G-code program.
Open Camatics and set the units. open the G-code file. From the File menu, click Open. This is the file we just made in PyCAM. Set up the tool. Define the tool. Set up our V-bit. Run the simulation. Inspect the result. Maybe this seems like a low-risk program, but checking the simulation output is good practice. On to the machine. With the power off, clamp your stock in the CNC machine. Fire up Linux CNC and start your machine control program. In my case, I use the Axis shortcut created by the stepper configuration wizard. Open the G-code program. From the File menu, click Open. Select the program we made in PyCAM. Home all the axes. Click these buttons to turn off e-stop and turn the machine on. Click Home All. I have my machine set up to Home Z first to make sure the tool is up and out of the way before moving in the X and Y directions from an unknown position. Touch off or zero all the axes. You can use the mouse, but I find the keyboard is more convenient. Use the arrow keys to jog in the X and Y directions and page up, page down to jog in the Z. In this program, the coordinate system origin is in the lower left corner of the eraser. For something like this, I use the point of the V bit to line up the X and Y by eye and use a sheet of paper to slide under the bit to tell when Z is just touching the surface. For the Z-axis, when you have it in position, click the axis identifier, click Touch Off, type 0, click OK. Do the same thing for the X and Y axes. If you have manual spindle control like I have, start your spindle, start the program, and enjoy the show. When the program's done, stop your spindle, power down your axes, and inspect your work. If all went well, your design is engraved. This program is extremely simple and can be useful for signs and scroll work where you want to trace lines. The process is not much more complicated to make pockets and cut around shapes. If there's enough interest, I'll make another video for that too. If you like this style of step-by-step instruction, please share and subscribe so you'll be notified when I post more. If you have questions, please post them in the comments. Read about more of my woodworking projects and tools at chipswoodshop.com.